All right, so a little more practice, a little more understanding of how to use pH. All right, when the pH of a solution is 12.124, we know that we can find the hydrogen ion concentration by taking 10 to the minus 12.24. All right, we know that when we have the hydrogen ion concentration here, we can take the negative log of it and find the pH. Okay, so let's finish up this little chart here. I think you guys should be able to do this. If not, go back to the previous chart and try to figure it out. Previous lecture, I mean, and try to figure this out. But let's see you do it. Push pause, finish it up, and then come back and we'll see how you did.
Okay.
All right, what'd you get?
Yeah, that's what I got. So the sum between the pH and the pOH is always 14. So to get the pOH in the first one, you just had to do 14 minus 2.33. And to get the hydrogen ion concentration, you just needed to go 10 to the minus 2.33. For the second one, 14 minus the 1.89 gave you the pH, 10 to the minus 12.11. Wait a second, did I say that right?
I think you said 10 to the minus 11.67. I'm not sure though, but you need to go 10 to the minus 2.33 to get the hydrogen ion concentration.
Yeah, I'm not sure if I said that right. But the last one there, 10 to the minus 12.11, will give you the hydrogen ion concentration.
Okay, very good. Excellent. So what's the pH of a solution if we have 1.2 times 10 to the minus 3 molar hydroxide ion?
Well, you can find the pOH and then 14 minus that, and that would be the pH, right?
That's right. Very good. So how would we find the pOH?
I'll let everybody at home do it. I'll give you a second.
Okay, push pause. All right. Did you do it? Okay. So what do we do here?
Negative log of that hydroxide ion concentration, which is 1.2 times 10 to the minus 3. And then 14 minus that should be your pOH, or your pH.
Okay, very good. All right. Strong ions ionize 100% in water, right? So the concentration of the hydrogen ion after you put a strong acid into water will be equal to the strong acid's concentration to begin with. So, for example, what's the pH of 0.1 molar HCl?
The pH? Oh, I see. So because we put 0.1 molar HCl in, we know that 0.1 molar hydroxide, or hydrogen ion, is in solution. Is that right?
That's right. And then what do you do with that value?
You just take the negative log of 0.1?
Very good, because the negative log of the hydrogen ion concentration is the pH.
Okay, that makes sense.
Now, if we think about it in terms of an ice table like this, put in 0.1, and the change is minus 0.1, all of this translates or dissociates into hydrogen ion and chloride ion, and then we can take the negative log of this hydrogen ion concentration, right? Same thing that we did up here without using the ice table. And the ice table is not important for strong acids. When the ice table becomes important, however, is for weak acids, right? So strong bases also completely dissociate. So if I have 0.5 molar potassium hydroxide, what is the pH of my solution?
I'm not sure. How do you know that one?
Well, what happens when I put this strong acid, calcium hydroxide, into water?
It dissociates and you separate into, yeah, that right there, right? You get 2 hydroxide ions.
Very good. So if I put in 0.5 molar calcium hydroxide, I get out what concentration of hydroxide ion?
Twice as much, so 1 molar.
Okay. Now if I have 1 molar hydroxide ion, can you tell me what the pH is?
Yeah, I guess so. Negative log of 1 molar.
All right. Negative log, where are we at here? Negative log of 1, that's the hydroxide ion concentration, is 0.
0. What do we do with that? Oh, and then 14 minus 0, so it's 14. So the pH is 14.
That's right, the pH is 14. If we think of it in terms of ice table, this is how much we start with. All of it dissociates. This is the resulting concentration of hydroxide ion, and negative log of that value would be 14. Okay, very good. What is the pH of a 0.5 molar solution of sodium hydroxide?
0.5 molar solution of sodium hydroxide. Why don't you guys try it at home?
That's a good idea, Fred. They'll try it at home, and when they're done, they'll come and see if they got it right.
I think you just have to. Are you ready?
Yeah, I'm ready. Go ahead. They have to push pause if they don't want to hear it.
I think you just have to take the negative log of 0.5. That gives you the pOH, and then you take 14 minus that value.
All right, I'll try it. Negative log of 0.5. There's our pOH. 14 minus that value. Our pH would be 13.6.
Yeah.
Okay, very good. 13.69, 17. Good job, Fred.
Thank you.